So this is the standard induction principle, although this is a how to solve it course. So we are not going to really talk about formal proofs per se. We are only going to write convincing arguments, like arguments which can be converted into formal proofs if needed. But at the moment, we'll not focus so much on proof writing rather than coming up with the proof idea. So this is typically how a induction proof is written. You talk about a particular property P. That property will be made clear from the question. So if you remember your matchstick game, there I was not there for the end of the class, but that property could be the property of player one winning the game. It is just some mathematical property. And you want to show that that is true. So P was player one wins if the number of matchsticks is not 4k plus 1. Or player 1 loses only if and only if the number of matchsticks is of the form 4k plus 1. This could be your property. Or 4n plus 1, where n is the parameter. You first establish the base case. So n is equal to 0 or 1. I mean the small cases. Base case is the initial few cases. Then you assume that you have somehow established this statement up to a particular value of n. Okay. And you show that this means that for the next value of n, the same statement has to be true. If you remember the way you went from 5 sticks to 9 sticks or something like that, something similar would have happened. You would have said, oh, I already know. I have showed the claim for smaller values of n. Now I will tell you that this implies that for the next value of n also the claim is true. And somehow this means that it is just always true. It's a bit abstract, but just it feels very natural, right? That if some claim is true for all values up till 47, and then I show it for 48, then it becomes true up till 48. Then I will show it for 49. Then it becomes true up till 49. Then I'll show it for 50. It becomes true up till 50. This way I'll be able to show it for any natural number. So the claim is just true. So the way to visualize this is via these dominoes falling. But yeah, let me not do that. Let me do that later. But here's something very important, that although induction, the way I said it, is a bottom-up principle, right? You start with smaller values and you somehow say that, oh, because I have been able to prove this via computation or like with some other argument, because I've been able to prove this for smaller values, now I'm able to prove this for the larger value. It is bottom-up, meaning you start with small things and you go to the bigger thing. When you think about induction, it always works the other way. You have the bigger problem in your mind. You should try to solve it using the fact that you have solved smaller problems. We will see this in action today, but we will see this more in action if we go for the Olympiad module. But this is an important thing to keep in mind. You will slowly acquaint yourself with this thing and realize this on your own. But it's good to just keep it in your mind that when you are thinking about induction, the best thing to do is to just imagine, okay, I want to solve this problem for n, for any integer n. Let me assume I have these solutions for the smaller problems. How can I patch them together to create a bigger solution? This is the way, or this is the way to smell induction. Right now, it's a bit abstract, but as we take more problems, and as you dwell deeper into induction, you will realize that this is the correct way, because oftentimes this property P that you have to prove is very non-trivial. It's not simply what the question is asking. You will modify what the question is asking by coming up with a clever property. You will prove that thing is true, and then you will say, because that is true, it also implies the question is true. So this indirectness is often seen in induction proofs, especially at like the higher Olympiad levels, or even in mathematical research, like hardcore, like even like state-of-the-art mathematical research. So always try to think of induction in the following manner. I have small solutions. I want to patch them together to create a bigger solution. Then naturally things will present themselves to you. Okay. So this is that picture that you guys probably saw in your last lecture, the domino effect kind of thing, that if you prove it for one natural number and you have somehow a way of flicking that thing so that it will automatically imply that it is true for the next natural number. That will be like you have an infinite spiral of dominoes and you just went to this base domino and flicked it. That is, you showed it is true for the base thing, and you also showed that if it is true for the base thing, it is true for its next neighbor. Then all the dominoes will just fall in line and everything, it will be established for all natural numbers.